Hey guys, this is Mrs. Finnemeyer. Today we are going to be looking at Chapter 1, Lesson 3, and this lesson focuses on multiplying and dividing monomials, but for this particular video, we're just going to focus on the multiplying monomials. So, just a little reminder, when we are talking about properties of exponents, we need to remember that there's two key terms here. We first talk about the base. That is the number that is written normally, the normal size, and then we also have the exponent, and that's the number that is written really tiny in the upper right hand corner. So be careful as you are writing your numbers that you make it obvious which one is the exponent. Now also be careful, 2 to the 4th power, that is not the same thing as 2 times 4. That is actually 2 times 2 times 2 times 2. And this is what it would look like. That is equal to 16. Now those 2's, the 4 2's that we have there, those are what we call our factors. So the exponent tells me how many factors there are of the base. So in this case there's 4 of them. So let's take a look at some examples here. Our first rule that we're looking at is called the product of powers. So if we look at this problem, it says 4 to the 3rd times 4 to the 5th. Notice the key here is you are multiplying these. That's why it is called the product of powers. So if we break that down, 4 to the 3rd would just be 4 times 4 times 4. 4 to the 5th would be 4 multiplied together 5 times. Now remember that originally this problem was 4 to the 3rd times 4 to the 5th, so we don't want to lose that original multiplication sign. Now if we look, this is just a bunch of factors of 4, and if we count them all up, we can see that there are 8 factors of 4. So that could be rewritten as 4 to the 8th. And there's that. Now we'll come back to that example in a second, but if we look at another one, now we have a base that is a variable. So a squared times a to the 3rd. Well, a squared is just a times a, and a to the 3rd is just a times a times a. And again, we are multiplying these, so we don't want to lose that multiplication symbol there. Now we have a bunch of factors of a, and if we go through and add them or figure out how many there are, we can see that there are 5 factors of a. So that would be a to the 5th power. Now if we look at both of those examples together, we can see that we have a squared times a to the 3rd, that equals a to the 5th. Well, let's take a look at these exponents here. So the a stays consistent, but the 2 and the 3, they become a 5. So what do you do with 2 and 3 to result in a 5? Well, we would add them. 2 plus 3 is 5. So this product of powers rule, that's really all it's doing, is it's adding those exponents together. And if we look at the other example, it still holds true. We now have a common base of 4 that stays the same, and we have those exponents of 3 and 5 that become an 8. Well, again, 3 plus 5, that would give me the 8. So, there's that shown. Our product of powers rule, this is on page 24 of your book. The key here is when you are multiplying, it only works when you are multiplying powers with the same base, so your base has to match. Then you are going to add their exponents. So those are the key words in that definition. And they give you some examples there with numbers. You have the common base of 2, and you are adding those exponents, 4 plus 3, which becomes 2 to the 7th. Again, notice that in the original problem, they are multiplying those like bases. So that is key there. And then with algebraically, that just means that they have variables instead of numbers. We have a to the m times a to the n, and that would be a to the m plus n because the bases match. So now let's take a look at two more complex examples. So here in example 1, we have 5x to the third times negative 2x to the fourth. And if we break that down, again, they are both being multiplied here. 5x to the third would just be 5 times x times x times x. We have the multiplication sign that we don't want to drop. And then we have negative 2x to the fourth, which is really just negative 2 times x times x times x times x. And we can do a little bit of rearranging here because everything is being multiplied. We know that we can rearrange this and have the 5 times negative 2 at the beginning with all of the x's following. We haven't changed the overall problem right now. So 5 times negative 2, we know that's negative 10. And if we go through and count up how many factors of x we have, we can see that we have 7 factors of x. So that would give me negative 10 x to the 7th. Now if you go back and look at the problem, we can see that that makes sense because we've got our coefficients here, 5 and negative 2. Because those don't have an exponent with them right now, we're just going to multiply those together, following the sign in the middle here. And then the exponents here, this 3 and this 4, we're going to go ahead and add those together and keep the base of x the same. And then in our next example, we add in parentheses, but it really doesn't change the overall problem from what we've been doing because we're still just multiplying. We haven't put any addition or subtraction or division signs. We're still just multiplying everything. So we can write that first factor in parentheses as a times b times b times b times b. There's that written out. Times 6 a's multiplied together times b, because there's only one b. Now as you can see, it's already starting to get messy and difficult to write out. So that's why we have these rules to save you from having to write all of this out. But if we go ahead and look at this problem and we say, well, how many factors of a do I have? Well, I have 2 here and I have 6. Oops, sorry, got a little messy. 6 over here. Well, that's just a to the 8th. There's a total of 8 a's. And then if we look at our b's, well, I have 4 b's, factors of b over here, and 1 over here. That's a total of 5 of those, so b to the 5th power. And so there we have our a to the 8th, b to the 5th. And that makes sense if we go back here to the original problem and look. A to the 2nd plus 6, because those are like bases, that's a to the 8th. And then we look at our b's, those are like bases, b to the 4th, and this one technically has an exponent of 1, so 4 plus 1 is b to the 5th. Alright, so what you're going to do now is you're going to try a few on your own. So on page 24, I want you to try the Got It problems A through C. And if you don't have your book, go ahead and just pause it and write these out on a sheet of paper. Okay, let's take a look at these. So problem A, the like base is 9, and so we're going to add those exponents. So we have 9 to the 3 plus 2, which is 9 to the 5th power. In B, we have a like base of A, and the exponents are still 3 and 2, so we're going to add those together, and we get a to the 5th. And then in C, we need to do a little bit of rearranging. We're going to get those coefficients negative 2 times negative 8 together, and then we have m to the 1st here and m to the 5th, and we're going to add those exponents. So that's negative 2 times negative 8 times m to the 1 plus 5. So negative 2 times negative 8 is positive 16, m to the 6th. So to summarize all of this, when we have the product of powers, that says when you are multiplying, again the key here being multiplying monomials with like bases, the bases have to be the same. We are going to add the exponent, so don't forget that.